Right, so these notes are on graphing rational functions, and since this is the first time we've ever looked at rational functions in a graphing situation, we only deal with the more simple examples this year, so a parent graph of 1 over x or a parent graph of 1 over x squared. If you move on in math, you look at all sorts of crazy denominators and things like that, but we don't do that in Math 3, we just focus on this. So if you guys recall, we do know that on the bottom of the fraction we have some excluded values, and that those excluded values actually in this case, when we graph, they become asymptotes, which is potentially a word that's new to you. So we're going to go ahead and write that at the top of our notes. Asymptote. I know that's a weird spelling. The P is basically silent, asymptote. An asymptote is an imaginary line that the curve gets closer to. So I went ahead and I graphed it on my calculator, so I typed in 1 divided by x. And the window, I went ahead and changed it. I made it go from -5 to 5 each direction, just so that it would be exactly the same size as what's on my paper. And so we have a vertical asymptote at x equals 0, which is the y-axis. So I'm going to go ahead and write this down. Vertical asymptote, x equals 0. So I would actually do this in colors. So vertical asymptote comes from right there. And then we have a horizontal asymptote as well. There's a y value that we can never have. And the y value that we can never have in this particular situation is 0. And the reason that we can never have 0 is because when you plug a number in for x, that means you're always going to have a fraction here. So if you always have an answer, then you're never going to have 0 as that answer. And so we have a vertical asymptote of 0 and a horizontal asymptote, y equals 0. And we always have to write these as equations because it's the equation of a vertical line, the equation of a horizontal line. And then to go ahead and get the points, I'm just going to look a little bit to the left of the asymptote, a little bit to the right of the asymptote. So I'll go ahead and look at -1 and -2. So -1 is -1, -2 is -0.5. And then I know that because of the definition of asymptotes that the curve would be getting closer to the asymptote as it goes on. And then for +1, I have +1. And for +2, I have 1/2. Again, it's getting closer to the asymptote. All right, so we're going to go ahead and just focus on this particular parent graph to start with. When we look at these parent graphs with the transformations, we're going to have y equals a over x minus h plus k. And the x minus h is the bottom of the fraction. It does not require parentheses because it's on the bottom, but you can think of it as having parentheses down there. So when we look at this, we're still going to have the a value still gives us our stretch or our compression. The k value still tells us to move up or down. The x value in here still tells us to do left or right, and it's the opposite of what we would think. And the interesting thing about rational functions is they don't have a vertex like what we've expected in the past, but they do have the two asymptotes, a vertical asymptote and a horizontal asymptote. And the interesting thing about it is those asymptotes come from the exact same spot in the equation where we used to find the vertex. So the vertical asymptote comes from the opposite of the number that's inside the function. And the horizontal asymptote comes from the number on the end. So we're going to find the asymptotes exactly the same way that we have found some information in the past. So if you look here, this graph, I should have made a bigger graph, that was my bad. But let's go ahead and look first for those asymptotes. So I have a vertical asymptote here at x equals -5. And this is where you're going, Miss Rice. That was a terrible graph for us to use. And then our horizontal asymptote is right here. Y equals -3. Yep, still horrible. And so if we were to label the transformations for this graph, we would say that we have moved left 5 and down 3. Okay, and I'm going to go ahead and graph this. 1 divided by parentheses x plus 5. So if you type it in like this, I'm going to have, if you're following along at home, and you should be, I'm going to type it in like this, -3, and I will show you guys in a minute why I would probably not type it in as a fraction. Okay, so type it in like this. We make sure that whatever we put in the bottom of our fraction needs to have parentheses around it. And I'm going to go ahead and hit my window button and make this go back to normal because this graph is too small. Okay, so we have an asymptote at left 5 and down 3, which is what we expected. And so when I look for points to put on my graph, I'm going to look for an x value of -5, and I'm going to go to the left of that and the right of that. So when I hit to look at my table, I'm looking for -5, there's the error message for my asymptote. So I have -6, -4, -6, -4. And then I have -7, -3.5. And then we make sure that the curve follows the asymptote because that's what curves do. And then on the other side, -4, -2, -3, -2.5. And again, we will follow the asymptote. Okay, so if we look here, the domain, we have an arrow going left, we have an arrow going right, we have all these x values, all these x values. So with the domain, we actually have all of the x values except for -5. That asymptote x value gets skipped, but we have all the decimals leading up really close to -5. We have all the decimals to the right of -5. In fact, if I hit the trace button, I'm going to go ahead and move it over here. Okay, so if we start at the left side of the graph, I've got my negative x values here. And if you watch the x values as I scroll right, I've got them. And then at -5, you just don't see -5 exactly. It's because it's skipping it as it hops from one line to the next. So we do have all of those x values, we just skip the -5. So I'm going to say my domain is from -infinity to -5, and I'm putting a parenthesis because I'm actually about to skip -5. And then I do u -5 to infinity. So that's how we write an answer when we're going to skip a number. We just put parentheses there. For the range, basically the same thing is going to happen. If we look at our negative numbers, we have all these negatives, and then we get up to -3 and we skip it, and then we have all the numbers above -3. So we're going to have -infinity to -3, but we're skipping -3, and then up to infinity. All right, for the X-intercept, I'm going to do second trace, option number 2, and I'm going to go ahead and do my left bound and right bound. So left bound, right bound, -4.667. If you're having a hard time with left bound and right bound, you can look on your graph. So I can see that my answer should be between -5 and -4. -5 is to the left of my answer, -4 is to the right. And when I type second trace number 2, when it asks me for left bound, instead of scrolling, I can just type -5. And then instead of scrolling to my right bound, I can type -4. And then I always ignore the guess, and I can press enter and get the answer. So your calculator is capable of having numbers plugged in instead of just scrolling every time. That's not a bad idea to do. All right, for the Y-intercept, we do second trace, option number 1, plug in 0. So we have 0, -2.8. There is no max or min, there's no mountaintop, there's no valley. Increasing and decreasing, if I take a little stick figure and I put him right here. So this is an x value of -infinity, and if I watch him, he's actually walking downhill. And he walks downhill until he gets to an x value of -5. I know that it's an arrow going down, but I'm not paying attention to the down arrow. I'm paying attention to the fact that he gets right up to that asymptote, which is an x value of -5. And then that stick figure drops off into the abyss and disappears. And so we have another stick figure who gets dropped right up here at that x value of -5. And this guy is also walking down, but this guy was like walking downhill. This guy's kind of walking like down into a valley. And decrease, and then that's a right arrow, so that's infinity. So for this graph, we're either going to have 2 increasing intervals or 2 decreasing intervals. You're not going to have both. So here I'm going to say for increasing, none. For decreasing, -infinity to -5, -5 to infinity. These graphs are not continuous because if you trace it with your finger, you have to pick up your finger to trace the whole thing. And for the end behavior, I'm going to look as x goes to the left forever and as x goes to the right forever. So as x goes to the left, the y coordinate is going to get closer and closer to -3. As x goes to the right forever, the y coordinate gets closer and closer to -3. So these graphs don't go up and down forever like we're accustomed to. They actually get closer to the horizontal asymptote. And so the y coordinates just get closer to whatever that number is for the horizontal asymptote. All right, let's go ahead and do the next example. So again, we can go ahead and look and we see that the vertical asymptote is -1 and the horizontal asymptote is +1. And if I write the transformations here, I do have left 1 and up 1. I also have the negative in the front, which is reflect over the x-axis, and I also have that 3 on top, which is a vertical stretch of 3. All right, so I need to go ahead and graph this. -3 divided by x plus 1, the +1 on the end. And I'll go ahead and make my window smaller again since it's big enough this time to see all of it. And so when I look at the graph, the table, I want to look at x equals -1 on the table because that's where the asymptote is. So there's -1, and I want to look a little bit to the left and to the right of that. So -2, 4, -3, 2.5. So this graph is a little bit further from the asymptotes when it gets started. It's a little bit stretched out because of that 3. And then 0, -2, and then 1, -0.5. So the domain this time we're skipping that x value of -1. So -infinity to -1, -1 to infinity. This time we're skipping a y value of +1. The X-Intercept, it looks, I can't tell if it's at 2 or not. It's somewhere between like 1 and 3. So I'm going to go ahead, and over here I can tell, like it looks like I drew it at 2, but I could have been wrong. So it's definitely somewhere between 1 and 3. So I do second trace number 2. I can say my left bound is 1 and my right bound is 3. And it was at 2. Guys, look how perfectly I drew that. I already know the Y-intercept because we had to graph it as one of our points. That's 0, -2. There's no mountaintop, there's no valley, so there's never going to be a max or a min on these graphs. So now I can go ahead and draw my stick figure. So I'm going to start over here at -infinity, and he is walking up out of a valley, And this is an X value of -1, and he walks up and he gets taken up by UFOs into the clouds, and then that's the end of him. And so then this other guy comes up out of the ground. He's probably a zombie of some sort. And he is walking up over a mountain to infinity. So for this one, we're going to say there's no decreasing interval, but we increase from -infinity to -1, -1 to infinity. So you'll notice that the increasing and decreasing intervals are the same as the domain, which makes sense because these graphs only increase or decrease, so that's going to be the whole answer. And increasing and decreasing intervals are always based off of X values, and that's what your domain is based off of. So it would make sense for those to be the same. Is the graph continuous? These are never going to be continuous. You're always going to have to pick up your finger to trace both of them, both of the curves. Again, as X goes left forever and as X goes right forever, you'll notice that we're just getting closer and closer to the asymptote on both sides. And so the Y value is going to be going to whatever that horizontal asymptote is, which in this example is 1. All right, so do not worry about the rest of the notes. We will talk about this parent graph, and then we will do this example when I see you guys in class.